In the first example, it says you're given f of x equals x squared plus 2x and g of x equals 2x plus 1. This is a review from Algebra 2, and I want to give you a head start, and I want you to do A, B, C, D on your own on that one. All right, you should be done with your 4. Let me have you look at mine. In letter A, I have x squared plus 4x plus 1. In B, you have to be very, very careful. If you are subtracting polynomials, subtracting functions, if it's a sum or difference, you have to insert the parenthesis in order to subtract the entire function. Letter C, you end up using FOIL. In D, you divide, and there's nothing else you can really do. You could factor out the x in the numerator, but nothing cancels, so it's okay. Do you guys remember this from last year? Pretty easy. Good. All right, the next one. It says find the domains of f of x over g of x and g of x over f of x. If f of x is the square root x and g of x is the square root of 4 minus x squared. So let's start with f of x divided by g of x. And we're going to make a neat connection to what we've been doing. If you want to find the domain of a fraction, you find the domain of the numerator, the domain of the denominator, and then you look for where those overlap because it has to work for both of them. Okay? So if I look at the numerator, the domain of the square root of x would just be x is greater than or equal to 0. No worries. In the denominator, normally you would say 4 minus x squared is greater than or equal to 0. However, you can't let the denominator equal 0. So we're going to set it greater than 0. Now, I have been hammering and hammering away at solving quadratic inequalities. Remember, they've been on extra worksheets and things like that. It's not because I'm trying to torture you, it's because you need to use that. So I'm trying to set you up for success here. So you factor it, and you find your critical numbers, which are plus or minus 2. Because this is strictly greater than 0, they're open circles, and then we test. If I plug in that x is 3, that's a positive times a negative. If I pick 0, I get positive. If I plug in negative 3, I would get a negative times a positive, which is negative. So this is from, whoops, sorry about that. That is parenthesis negative 2 to 2. So here's what you're going to want to do. Draw the numerator on a number line. So this is 0 closed to the right. The denominator is open, open, and in between. So you want to look at where are they both shaded at the same time? Where's that overlap? John?
Between 0 and 2.
Good job. Between, and it's actually a bracket at 0 and a parenthesis at 2. So that's the domain of the fraction. So here's what I want you to do. I want you to write g of x over f of x. Find the domain of that numerator and the domain of the denominator. Make little number line sketches and see where they overlap. While you're working, let me just go over a couple of housekeeping items. We're going to spend 2 days on 1.6. So 1.6, even though I'm going to finish the notes today, the homework's not due till Wednesday. We're going to get started on it tonight, try and get about halfway through it. Tomorrow we're going to do some group work and just practice to make sure we get everything down. Wednesday will be a review day, and Thursday we have a quiz, okay? So that's where we're headed. Now you've done most of this work already. If you look at the denominator, now x can't be 0 because that's in the denominator. So this is open circle going to the right. Now in the numerator, it can be -2 and 2. All right, who would like to try to write the domain of our answer? Stephanie, you got it?
Parenthesis 2, parenthesis 0, 2 bracket.
Good job, good job. Okay, parenthesis 0, comma 2 with a bracket. Any questions on this? Is this making sense? Okay, super. All right, recall. Do you remember fog from last year? We called this fog. It really is the composition. And you need to be comfortable with either notation because on the ACT or other standardized testing, you might see the little fog, and you need to make that connection that that's the composition of f with g. So let's review this. If f of x is x squared plus 2x, and g of x is 2x plus 1, if I want to do f of g of x, that means we are going to plug g of x as the input into f of x. So I'm really looking at f of 2x plus 1, and I'm going to go to f of x, and f of x says take the input squared plus 2 times the input. So my input is 2x plus 1, and again, it's like a direct substitution. You're doing 2x plus 1 squared plus 2 times 2x plus 1. And then let's just simplify that. I get 4x squared plus 4x plus 1 plus 4x plus 2. Collecting like terms, I get 4x squared plus 8x plus 3. All right, I'll give you a head start on me. Go ahead and find the reverse direction, g of f of x. Alright, g of f of x means we want to put x squared plus 2x inside g of x as the input. So this is 2 times the input plus 1. So that's 2x squared plus 4x plus 1. Any questions on composition of functions? You guys remember this? All right, now in the next example, we want to do just f of g of x, and then we're also going to talk about the domain. So f of g of x means we want to do f of the square root of 9 minus x squared. So this means we're going to go to f of x, and where we see the input for x, we're going to replace it with the square root of 9 minus x squared. So this would be the square root of 9 minus x squared being squared, minus 9. Well, what happens with the square root and the square?
They go away.
Good, they're going to cancel, and I get 9 minus x squared minus 9, so that's negative x squared. Now, it didn't come out and ask for the domain, but we're going to work on domain. To find the domain, let's write this down so you have this in your notes. To find the domain of a composition of functions, it's a little different than a fraction, but similar, okay? Step 1, find the domain of the inside function. In this case, that was g of x. Step 2, find the domain of your answer to f of g of x. Okay, so let me repeat where we are up to this point. To find the domain of a composition of functions, number 1, find the domain of your inside function. In this example, the inside is g of x. Step 2, find the domain of your answer to f of g of x. Step 3, find where they overlap. The reason why I didn't say anything about the previous example is that if you look at this one up here, what's the domain of 2x plus 1? All real numbers. And what's the domain of the answer? All real numbers. So that was not very interesting. The same thing is here. The domain of the inside is all real numbers. The answer is all real numbers. So that's just okay. So let's do this. The domain of my inside, okay, the domain of the inside, I would set 9 minus x squared greater than or equal to 0. And you guys have to remember that this is a quadratic inequality. A quadratic inequality is not done like a linear inequality. You've got to do critical numbers in a test point. So this is between negative 3 and 3. And then my answer was negative x squared. What's the domain of negative x squared? All real numbers. So then the domain, where do they overlap? I've got from negative 3 to 3. And I've got the whole number line. So where are they shaded in the same spot? Negative 3 to 3. Beautiful. So the domain, it won't always work like that, but it just happened to on this one. Okay? I want you to find or flip over to the back of your notes. It should be blank. Let's do one extra one. I want you to find f of g of x and then it's domain. Okay, so we'll practice both of those items. And then we'll go back to the note sheet. And what I'm passing out, we're going to work on this at the end of class today and tomorrow in class. So this is not homework I'm passing out. It's some group work we're going to do. So just hold on to it for now. Alright, for composition, did you get 1 over the square root of x and a minus 2? Okay. Now, let's talk domain. This one's very, very interesting and a little challenging, okay? So I'm excited to see what you guys think. So the domain of the square root of x would be x is greater than or equal to 0. You do step 1, the domain of the inside. So on a number line, that's 0 and to the right. Now the domain of our answer.
Okay.
Okay, how about this one? What would be the domain of my answer? Oh, Emily. What? Okay, so you're on to something here. You're saying x can't be 4, but can I plug in negative 5? No. Okay, but I can do 0, right? You're onto it. You really have it here. She's on the track of, if you plug in 4, that would make it 0. So x can't be 4 is a no-no. But it's not necessarily x greater than 4, because I can plug in 0 and 1. Tyler, do you have it?
I have bracket 0, comma 4, parenthesis, union, parenthesis 4 to infinity.
Okay, so you were on it, Emily. It's this one, but with a qualifier that x can't be 4. So x really is greater than or equal to 0, but this is a fabulous, fabulous problem. So here's what then Tyler pieced together is he had bracket 0 to 4 parentheses. So it's saying x is greater than or equal to 4. Poor Josh just walks in on this one. He just walks back in. Sorry, Josh. This is yeah, that's not a good problem to walk back in on, huh? And so then it's everything greater than or equal to 0, but not 4. And so where are they overlapping? They're overlapping here. Okay, this was excellent. This was a rich problem. Here you go. Okay, so let's get back to the notes. Flip it back over. It says express the function h of x equals 1 over the quantity x minus 2 squared as a composition of two functions. So what we're talking about here is, can you think of what could g of x be as the inside function and f of x is the outside function that would produce h of x? Tyler, what do you think?
I had f of x equals 1 over x squared and g of x equals x minus 2.
Good job. Okay, so he's really quick on this. So what I want you to look at is g of x is like the inside, and then what are you telling the function to do to the inside? You're saying take 1 over that something being squared. So let's show that. If I'm doing f of g of x, that's an x minus 2, and then according to his f of x, you're plugging in the x minus 2 and then squaring it, okay? Alright, let's do one more. Like this, and you guys put a star next to these because you're definitely going to see this on your next quiz. So in h of x, I would do one teeny tiny little simplification because it doesn't look quite so clear to me the way that it's written. If I can rewrite it as x plus 1 squared minus, and if I insert a parenthesis, that actually is x plus 1. So if h of x is f of g of x, you want to think about that g of x is the inside. F of x is what are you doing to the inside. Okay, does somebody else want to try this? What do you think g of x might be?
Would it be x plus 1?
Good job. Okay, the inside is x plus 1. And then Stephanie, can you take it the whole way? What are we doing to the x plus 1?
Squaring it and subtracting.
Good job. You're squaring it and subtracting it, but that's globally x squared minus x. Okay.